Hey everybody, Mr. Judson here. So a couple things real quick. First of all, I accidentally made this incredible discovery on Tuesday, I guess, or Monday when I was making the videos. My family had too many things going on. We were overwhelming the Wi-Fi, and so I walked over to a school that I live close to, and I was able to upload our lessons in about 5 minutes compared to 3 hours at home. I don't know if that's just how good Tacoma's Wi-Fi is or how bad mine is. But at any rate, it's going to save me a lot of time. And so I was looking at the kind of what we still have left to accomplish, the amount of time that we have left in the school year. I've talked about going to 3 days a week for a while now, and it seems like something always comes up where it prevents me from being able to do that. The fact that I can now upload these videos in about 5 minutes, it's kind of funny. I just go sit by the front door of the school and I'm able to connect into the Wi-Fi. So if you guys ever have trouble, there's something else you can do. Just take your computer and go stand by Wilson High School and you can upload or download or whatever. So anyway, starting next week, we will move to 3 days a week. And those 3 days will be Tuesday, Wednesday, Thursday. It's too hard for me to go Monday, Wednesday, Friday, because usually I start making my videos on Monday. So that'll be the plan. And I think we also need to do that because part of our schedule is we need to get a decent review in. We can't just do this Central Washington final without some good preparation for it. Another piece to that is calculus class. I've talked to B-Ray and it sounds like she'll let me set up sort of a drive-up situation where you come in and turn in your T89 graphing calculator because you're not allowed to use that on this test. And at that time I will check out a T84 calculator to you. So we'll have more details on that later, but I'll probably just set up right in the parking lot and you guys drive up, turn one in, check out the other, okay? Alright, so anyway, let's go ahead and push forward with what we've got for today. Alright, so we have one more day of just solving integrals using basic integration. I think the good thing about this section is, we in Chapter 7 we were doing everything on the calculator, and it's easy to forget all of this stuff that we learned about how to solve an integral. So yeah, make sure you're doing this without your calculator. There's no special prizes for just punching that into the calculator and writing down an answer and calling it homework. So we want to be able to get these on our own and then check them with the graphing calculator. All right, so you guys go ahead and try this one. All right, so this just looks like, integral of a secant. That's a natural log, absolute value, secant x plus tangent x, or u. The thing is we've got something other than just x here, so we need to do a substitution. So I'm going to let u equal 4x. That way du is going to equal 4, and I just took the derivative of x. So I need to see a 4 dx out here, which means I want 1/4 in front. And so now I could write this as 1/4 the integral of secant of u du. And so the answer to that would be a natural log absolute value secant u plus tangent u. Still have this 1/4 out in front and then plus c. And so now I just need to put my u value back in there. So 1/4 natural log absolute value secant of 4x plus tangent of 4x. So that almost looks like it's just one of our basic formulas. All right, let's try another one. All right, you guys go ahead and give this one a shot. All right, so again, we need to have this sort of checklist that we go through in our heads. Like I look at this and I see a fraction, so right away I'm thinking u prime over u. Well, the fact that there's a square root here, that kind of messes that up. So I don't really feel like that's going to be a u prime over u. Second thing I look at is almost always when you see a square root, you want to think of that as something in parentheses raised to an exponent. And usually that means substitution to us. So if I was to rewrite this problem this way, I've got a cosine of x raised to the negative 1/2 times sine of x dx, then what I can do is let u equal what's inside the parentheses. So u is going to equal a cosine of x, du is going to equal, derivative of that would be a negative sine of x, and derivative of the angle would be 1, and I just took the derivative of x. So I need to see that negative sign in here, so I'll just put a negative 1 there and a negative sign out in front. And so now I could rewrite this as a negative integral of u to the negative 1/2 du. And so I now have u, if I add 1 to that, I get u to the 1/2. If I divide by 1/2, that's the same as multiplying by 2 over 1. Still have that negative sign out in front, and then plus c. Remember, it's really this, and that negative sign gets distributed. We've talked about this several times. But c can be a positive or negative number. So by writing plus c, we're still writing down the correct thing. All right, so what I get for my final answer is a negative 2 root cosine x plus c. All right, you guys try this one. So, again, I'm going to go through this checklist in my head. I see a fraction, so I'm thinking u prime over u. But that's not the derivative of, the cosine is, but that plus 1 kind of messes us up. So there's no parentheses raised to an exponent, so it's not a substitution problem. So the next thing I'd want to try is maybe splitting this up into two different fractions. And so if I did that, I would have the integral of 1 over sine of x dx plus the integral of cosine x over sine of x dx. And so I would think of that as the integral of a cosecant of x dx plus the integral of a cotangent of x dx. And these are basic formulas. This was off our formula test. And so the integral of a cosecant is natural log absolute value cosecant x plus cotangent x, and that's got to be negative. Cosine over sine, this is a u prime over u. Derivative of sine is a cosine. And so that's going to be natural log absolute value of the sine of x. So that would be positive, plus c. There it is. All right, so let's try this one. In the square root here, I've got 4x squared minus 8x plus 3. So I guess that, this idea of going through your head and having this checklist of things you're looking for, right off the bat, I look at this and I think arcsecant. I've got a square root in the denominator. I've got something on the outside. That only happens with an arcsecant. So I'm probably going to have to complete the square here. So let's go ahead and rewrite this. I've got 1 over x minus 1. And then if I write this as 4x squared minus 8x, I'll put that in parentheses. and we'll put the plus 3 out here by itself. So to complete the square, I need for this to be just an x squared. I don't want that number out in front, so I'm going to have to factor a 4 out of each of these. So this integral now becomes x minus 1 times the square root of 4 times x squared minus 2x, and then plus 3. Now I'm ready to complete the square. So what I want to do is I want to take half of this number, which is -1, square it, you get a positive 1. And so what I really just did is I added 4. If I distribute this back in, I've added 4 to the problem, so I need to subtract 4 out here. And then I still have dx. So now this problem has become the integral of 1 over x minus 1 times the square root of, I'm going to write this as 4 times x minus 1 squared. This will be a -1, so minus 1 squared. So now I can think of my a value as being 1, and then dx. So my u value is whatever's being squared here. What's being squared is 2 times x minus 1. And so that means that, if I multiply this out, I would get 2x minus 2. So u prime is going to be just 2. I need to see that in the numerator. So I've got to do a little bit of work here. And then my a value is just 1. All right, so I need to see u out here. I don't see that 2, so I need to put a 2 in here. And I also need to see a 2 in the numerator. So when I do that, 2 divided by 2 is 1. I haven't really changed anything. I don't have to do anything to the outside. So this integral is now set up the way that I want it. And so it's an arc secant, so I've got 1 over a, which is just 1 over 1. Arc secant of absolute value of u. So I'm going to say absolute value of 2 times x minus 1 over a, which is 1, plus c. So really what I have here is arc secant, the absolute value of 2x minus 2 plus c. There's my final answer. And again, make sure you're checking all of these on your graphing calculator. Unless the answer's in the back of the book, you can check it that way. But we want to make sure we're getting things right. You guys, the number one thing that is irritating me beyond belief is up to yesterday, I think we only had one person check the answers on that chapter 5-6 test. Come on, how do we know if we're doing things right? There's a lot of us that have a Central Washington final coming up. And if you're not checking your work to see if you're doing things right, then really all you're doing is spreading a little bit of graphite on a piece of paper and calling it learning. Maybe you're getting it right, maybe you're not. I don't know, but we have to check to make sure. You can't just push forward without knowing. So take the time. If this is not something that's in the back of the book, punch it into your graphing calculator. Make sure we're doing things right. Okay? All right, let's try this one. So again, I start going through this checklist. I see a fraction, there's no parentheses, so we might want to think u prime over u, but the derivative of this would be 18x, and it's hard to get variables. Easy to get numbers, hard to get variables. So my next thought is, this looks like an arctangent. Right? There's no square roots in here, so it's not an arcsecant, it's not an arcsine, it's just a squared plus u squared. So let's just write that as things being squared. So I've got 1 over 2 squared plus 3x squared dx. And so when I look at that, my u value is going to be 3x, so therefore u prime is going to be 3, and my a value is going to be 2. So I need to see u prime up in the numerator. So I will multiply this by 3, do 1/3 out in front, and I think we got what we need. I've got 1/3. I need 1 over a, so that's 1/2 arctangent of u over a, so 3x over 2 plus c. And so our final answer here, 1/6 arctangent of 3x over 2 plus c. All right, there it is. That's what we have for today. All right, so here's our next assignment. We're on number C10, page 522. We're going to do 31 to 49 odd. And then next week, starting Tuesday, remember we're going to go 3 days a week. We'll start with what do we do with integrals that we don't know how to solve? All right, that's our goal kind of the rest of the way through. All right, that's it. You guys have a good weekend. Stay safe. See you on Tuesday.